So as we start our previewing for quiz 2 here, just wanted to take a look back one more time here at some of our logs and growth functions, especially the growth since it's been a little while now. So condense each expression to a single log. I'm not going to completely write out again our entire idea here of what order we want to take things in. I will do this just to kind of get us thinking about it again. Okay, condense and expand, a little bit different. Okay, when we're condensing, here, I'll do this. And maybe you want to do this at the top of your paper. I don't know, maybe you just want to watch mine. That's fine. When we're condensing, we're going to do power first, product second, quotient third. That will be the type of thing I'm willing to give you when we get to a quiz. The thing I'm not going to do, which is why I'm not going to write it on here, is I'm not going to put the divide becomes subtract, multiply becomes add, coefficient becomes exponent. That's the thing you're going to need to know. So when I'm doing these, and I'm trying to condense, if I have coefficients, my first job is to turn them back into exponents. So I've got log a to the 6th minus log b to the 24th. So that'd be my first job. Okay. Then, and did I just put the condensed ones with the, oh no, I didn't. Okay. Yeah. If I had a product, which would be in this case plus, since we're going backwards, I don't see any pluses. Quotient would be if I have minus, then I'm turning back into divide. I do have minus. So my last step here, because again, single logarithm, I should only see the word log one time when I get to the end. So I'm going to have a to the 6th, the minus becomes my divide, b to the 24th. Single log, exponents back in place, no more adding or subtracting. And I've got my answer. So that's one of them I'd be looking at. Okay? The other one we'll take a peek at is 2. I'll move this a little bit so we can see this a little easier. And I run through that same process. I go, okay, no coefficient, no coefficient. Ooh, coefficient. Okay. Stick that guy up there. And I wouldn't try to do multiple steps at a time, just because the odds of something going bad at that point are pretty good. If you want to turn the 11 squared into its value, which would be 121, that's fine. But leaving it this way shows me you know what you're doing. Product in this case would be, do I have any pluses that need to turn back into times? Oh, yeah. So here, again, single log, 7 plus becomes times when I'm condensing. 2 plus becomes times when I'm condensing. 11 squared. Single logarithm. And I'm set. Okay. Bless you. So when you're doing these, when we're condensing, again, coefficients become exponents. That's my power. Add becomes multiply. That's my product. Minus becomes divide. That's my quotient. When I get down a little further here into expand, the order just flips. So when I get to expand, quotient is first, so divide will become subtract. You're like, oh, so everything's just flipping, literally, the order and what I'm doing operation-wise. And it's true. Product goes from multiply to plus. And power goes from exponent to coefficient. I'm just undoing the stuff that we were doing up in part 1. So when I get to a problem like number 5, I look first, I'm like, okay, do I have any division? No. Do I have any multiplication? Yeah. Okay, this is a to the 5th times b to the 6th. So here, I'd have log a to the 5th. When I get to the multiplication dot, it becomes plus. And when I'm expanding, every single part is going to get a log. And so finally then, I get to the last part, power. Do I have any exponents? I do. Those guys become coefficients. And the nice thing about doing them in this order also is, you know when you get to the third one, you're just done. You're not having to sit there and go, well, did I forget a part? You know, is there another piece I can do still? And we just kind of look at it that way. Yeah.
When we lose points on the quiz mark, we don't show all the sets that we did?
If you can do multiples and still get to the right spot at the end, I have no problem with that. Now, the advantage, though, of showing a step in the middle is, let's say you try to do it in one step, and the question is, can I just go to the answer if I'm feeling comfortable? If you make a boo-boo in going straight to the answer, now I can't do anything partial credit-wise because I didn't see what your thought process was. But yeah, if you're feeling that comfortable, you go for it. Good question. And then 8, we're kind of running the same way with one small exception. If I've got an exponent outside the parentheses, like I do in 6 or 8 here, we're going to do one step first. We're going to take care of that right away so it doesn't confuse us. So right away, I'm going to move these. I'm going to do my exponent rules. And when it's power to power with exponents, we're multiplying them. So I'm going to rewrite that first so I don't have an exponent on the outside. So once I do that, now I can start working through my little checklist here. So I go, okay, do I have a quotient? Do I have divide? Certainly do. So I'm going to have log a of 20, and the divide becomes subtract. Minus log b of 5. Do that first. Do I have any multiplying going on? Nope. I got exponents. So nope. Do I have power? Yep. Exponents are going to turn back into coefficients. Once I'm to step 3, I'm A-okay. I'm ready to roll. So again, condensing and expanding, it's about the practice. So you know when you're going through what these words mean, because if you don't know what they mean, it isn't going to do you much good to even have the list, okay, if you don't know the operations that go with them. When we go into rewriting form, okay, most of the time I'm going to be nice and put it where you'd be able to check it on a calculator if you weren't sure. So we've talked about this some. This one I'm not going to rewrite the form. I'm just going to try and talk you through it. So again, my little number when I'm looking at my logs is called the base. So when I'm doing stuff in exponentials, my base is my big number. And we've talked about how the exponent's on the other side. And then that would leave me with this as the answer. Now, if it's all numbers, if there's no variables involved, I probably am going to take the quick little bit of time to go ahead and see, hey, is this statement true? Because if it is, now I doubly know I did it right. So we'll take a moment here, and we'll see 4 to the negative second. Oh, it's a decimal. Math, enter, 1 over 16. Okay, whoops, 1 over 16. So I know that I'm right, and we're in exponential form. So you can play with that, a little bit if you need to. Not a bad idea. Now, we're going to want to kind of stay on flip here, because when we get to the next part, It's just the opposite of what we were just doing. Okay, rewrite in log form. So I think for a minute back to what I was just doing. I go, okay, we said that was the base. When I'm talking about a base with my log, the base is the little number. Okay, I remember that part. And then I think a little more and I say, hey, the exponent was the answer before. And then all that leaves me with is the 3. You're like, okay. Is there a way to check this? Mm-hmm. Because remember, if I want to check, I can do change a base here, which again is the log of my big divided by the log of my little. And let's see if I do that in here, if I get the same thing back. So log of 3, again, log's down by your 7, divided by log of 243. Math, enter, enter, 1/5. Bingo. Okay. And if it's not a number sometime, you're just going to have to trust yourself or look at your other ones to see if that's going to work. Okay. Now this next portion I did purposefully, because we're going to start moving from the logs after this section back to growth and decay a little bit, and I want to make sure we're keeping these things straight. So identify the domain and range, show the end behavior, sketch the graph. Okay, first things first, whenever we're doing any of these, it helps if you look at what the shifts are first. Okay, my parentheses is always going to be my left or my right shift, but it's the opposite of what we think, so it's x minus h. So here, we'd be looking at right 1, and my number on the outside is my up or down, so we get up 3. When we're dealing with logarithms, okay, my focus is going to be on my left-right. Why is that? Because when we're doing logs, our asymptote, our little dotted line that's kind of our border, normally is at 0, but if I move left or right, it moves with it. So here, my asymptote moves to the right one. And what does that mean? Well, when I go to do domain and range, my domain will always move with that left or right shift. So if I move right, this is going to be that positive number. If I move left, this would be the negative number. So I can kind of use these 3 to check each other. My range, when it's a log, never changes. It's just infinite. And when it comes to the values to plug in, that's going to be up to you. Because we've looked at this several ways. One of the ways we talked about before, and I'm going to show both on this one, is to take your parent points, your 1, 0, and your 10, 1. Maybe you actually even just kind of draw them in lightly. You don't want to do them real dark because they're not the actual points. And then I just take my shifts, right 1, up 3, put a dot. Okay, this is kind of crazy out here. Right 1, up 3, put a dot. And remind myself this graph keeps going. And I even with this one, if I'm more visual of a learner, there's nothing wrong with that. I can always type it into my calculator, pull up my chart, okay? There's my first error message at 1. That told me where my asymptote was, where my domain starts, in case I forget. But let's check out the points I'd get from the calculator. 2, 3. There it is. Okay, so I always got a backup plan. And my other points way out here in the boonies at 11, 4. Not too bad. If I look at the picture, I've got to remember, though, don't just be a picture copier. If you are, you're going to draw that as your graph, and it's not going to be right. It's going to look more like a square root function. I just can't see it coming down because of the asymptote that's there. Now my last part here is showing end behavior. So now that I've got my picture, here's where I'm going to have to pay attention and start to make connections with things. My range, okay, these values always go with the f of x part. Why? Because range is y's and so is this. So when I'm doing logs, that's going to be kind of my no-brainer part. Stressing that's with logs. When I'm trying to figure out my x values, that's my domain. So here's how my thought process is going to go. And I can start with either one, okay? As y is going down, because when we're looking at y, negative infinity is down. As I'm going down, am I getting closer to going forever to the right, or am I getting closer to 1? Well, I'm getting closer to my asymptote. So I'm getting closer to 1. As y goes up, what's happening to x? Am I getting closer to 1 or closer to positive infinity? Well, it looks like I'm going forever to the right. And I can make that connection. But as long as you remember, domain goes with x, range goes with f of x, or y, no matter what type of problem this is, log, growth, decay, it's not going to matter. You're going to be okay. But you just can't make the assumption. So that's our logs. Now, like I said, as we flip, we're going to start transitioning into review with growth and decay some. I go, oh boy. Okay, growth and decay. We're going to do a couple of these because it's been a while. Sketch the graph of the function, name the domain and range, show the end behavior. Okay, now maybe I don't remember some stuff with this as far as my graphing goes. That's okay. We got a backup plan. So 3 times 1/2 to the x. So let's see, what can I remember? Should this be growth or decay? Okay, decay. Because my b value is 1/2. So it kind of reminds me, okay, this graph should be going down to the right. And as I'm waiting, there it goes. I'm like, I was a little nervous for a minute. There's my graph. Okay, so I'm feeling pretty good. Now, this won't necessarily always give me a ton of whole numbers, but I'm not just going to sketch the graph and kind of be like, well, you know, whatever, I'll just plot some points. I need to pay some attention to what I'm doing here. Because as I go down, I notice I'm getting really, really close to 0. Because that's where my asymptote is, because I didn't have any shifts. And we'll talk about that on the second one that we do. So once I get my graph drawn, I'm ready to do domain and range. Now again, this is not a log anymore. You're like, uh-oh, what does that mean? It means now my domain is the one. Forever to the left, forever to the right. I can see it visually too if I forget mentally. And my range goes from bottom, really close to 0, to top, up forever. So here's our deal with that. This range will stay the same unless I have an up or a down shift. Okay, so it's like the opposite of my logs. When I get to my end behavior, I'm going to have sitting in the back of my mind, okay, Harty said before, make the connections, don't just assume. Remember, my range values are going with my f of x. My domain values are going with my x. That hasn't changed. So this time, my no-brainer is going to be my x's. And I'm going to use those to figure out where my f of x or where my y goes. So I think about it for a minute. I go, okay, as x goes to negative infinity, as x goes to the left, what's happening to y? It's going up, 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 up. So that must be the one that's infinity. So I hope that means this one's going to be 0. As x goes to the right, to positive infinity, what am I getting close to with y? Oh, we're leveling off. And I can get it. So use your eyes to help you if the whole thing of did I work long of it to memorize it part isn't working for you. Okay, we'll look at it that way. And so we're going to do the same thing on 21 together, except this time we're going to have some movement going on. And we're going to try to make a connection with that. So here's what we've got working. Okay, on 21, I have two shifts. My shift up in the exponent is my left-right. So since it's the opposite, I'd be moving right 2. And up 1. Okay? When we're doing growth and decay, it's the up and down that matters. Well, why is that? Because it's the range value that's moving. So once again, I want to look at a picture. I need to look at a picture. Only thing here I need to be careful of, whoops, besides the fact that I need that to actually be an exponent. Oh my gosh, Harty. Silly man. It doesn't like me doing it that way. It does not want to go to an exponent on its own. Okay, I can take care of that. If it doesn't want to go up into little exponent mode, that's okay. We'll just put it in parentheses. We can adjust. And then we just got to make sure we close them before we get to there. I wonder if 0.5 would have worked. Well, we'll check that in a minute. So again, I notice, should be decay. Let's see. There it goes. Okay. So I see my decay. I pull my chart. Start grabbing some numbers here. So 0, 17, 1, 9. And I don't have to do every single one, but let's do several, at least with the whole numbers, so we're fairly accurate with things. But notice something as you scroll down. I'm not going to 0 this time. This time it looks like my cutoff line, my asymptote, would be at 1. Why is that? My graph shifted up 1. So what's that going to mean when I get to finding my other info? Is it going to do anything to my domain? Nope. But is it going to do something to my range? Yes. Normally my range is at 0, but I moved up 1. So that's where my range starts now. Connection between up and down and my range value, sort of like the left and right did with my logs. And so when I get to my end behavior, my domain still gets to be my no-brainer part, just like it was up above. My range, though, okay? Again, I take a peek. As x is going left, as x is going to negative infinity, up, up, up forever. And as long as I get the first one, now I know, as I go to the right, towards positive infinity, I'm approaching 1. Lots of connections to be able to make. And again, even if I didn't remember the little tricks, I visually can see it. So that's the type of things we're trying to take a peek at. Now, the rest of this is going to be a little bit more just, well, I don't want to say informational, but it is. Okay? 22, 23, 24. What are the transformations? What are the shifts of each function? Remember, when we're doing growth and decay, the exponent is left, right. Out here is up, down. So here, minus is going to be right, plus is going to be left. It's the opposite of what we think. The end will be what we think it is. Negative is down, positive is up, just like it's been. And then is it growth or decay? Now we got into talking about these on the others. Here my b value is a half. If it's less than 1, it's going to be decay. If it's greater than 1, it's going to be growth, except for one exception, which we're going to see here in just a moment. But again, I've got to be ready for either of these words. If I see the word transformation, I've got to know that means shift. And I'm just asking for like up, down, left, right, and that type of good stuff with those. So when we get down to our fixed number 26, again, if you popped in a little late, number 26 was supposed to have a negative exponent on the x, but it kind of didn't. It does now, though. Growth or decay, be careful. Okay. Because at first you'll look and you'll say, hey, my b value is 5. It's growth. Not so fast. Okay. Here, this is going to be decay. Why? Right, not just that it's a negative exponent, but because the negative x turns 5, or 5 over 1, into its reciprocal. And now that that value inside is 1/5, now it's less than 1, which makes it decay. If this would have been a fraction to the negative, it would have turned it from decay into growth. So if you were ever asked a question, let's say, on why, is it growth or decay? Why? You can't just say it's a negative exponent, because it could turn decay into growth or growth into decay. So we need to talk more about it flips it. It makes the reciprocal. Some kind of word like that, just to get you thinking a little bit. So just a thought. Now, this next page, I'm not going to do a whole lot. We like pounded these before, okay? The biggest thing I'm going to remind you when we get back here is you've got to turn your percentages into decimal form. Okay? Take the percent, divide it by 100 if you're not sure on what the decimal form would be. So like here, for instance, my rate is going to be 0.12. If you use 12, woo, that'd be some growth population. It'd be more like a population of bunny rabbits or something. Be reproducing so fast. So I've got to make sure that as I'm doing these, I pay attention also to words like increases, which means it's going to be plus in the middle. Or depreciates, which means I'm going to put a minus in the middle. But I want you to actually think on some of these. So like I said, I'm not going to say a whole lot as far as plugging them in and thinking. If you kind of start looking, you're like, what? The key up front gives more instruction if you need it on finding your answer. And when we get to 30 and 31, okay, this is the formula we use. The issue we've had before is, what about this n value thing? Okay? We find the word compounded. The word after it will tell me what my n value is. How many times does that event occur in a year? Weekly occurs 52 times. That's my n value. If I'm given the amount of time, that would be my t. If I'm not, I may be being asked to find something else. For instance, 31, I'm not even given a starting amount, my p, my principal. You get to make one up. Okay. But again, there's the word compounding. The word after, monthly, happens 12 times a year. That's my n. And this is one on 31 you'd have to do on your calculator, because how long will it take for my money to double? I got to figure that out once I choose what my starting value is. We've done a ton of those, so that's why I'm going to hope you can do that one on your own. And if not, try some things out, check the answer. Oh, yeah, that's how that runs. We'll talk more about that when we get to the preview tomorrow. And finally, I am going to do the two on the back with you, just because there were some issues on that other quiz, and I want to make sure we got this. And it'll show up again on the review tomorrow anyway. Okay, we need to decide between two job offers. pi r squared offers you a base salary of $25,000 with a $900 annual raise. 8 bun 5 offers a $22,000 base salary with a 7% annual raise. And again, we're making the adjustment on 8 bun 5 because Harty boneheaded putting the equation in here. That's what it should have been. And so we're going to have two questions we have to answer. When will 8 bun 5 salary be more? And if you plan to work in town for the next 10 years, which offer is better and why? So let me keep the equations on the screen here. We're going to go to y equals, and we're going to type both of these in. So 25,000 plus 900x and 22,000 plus, no, not plus, Harty. 1 plus 7 to the x. So, I get that in there. I'm going to look at the chart. So, I start to look, and I go, okay, at the start, pi r squared offers me more money. So I start scrolling down, and I'm trying to see when the number in the red column in the second column gets bigger. And I scroll, and I go, ooh, that was pretty quick. Okay, we're in year 4, and it's already bigger. So even if we just said, okay, well, it's into year 4, so 4 years. We talked about you could do the range. If you did 3 to 4, that'd be okay. So if I plan to work in town for the next 10 years, which offer is better? I mean, I can see all 10 years in my chart here. Which one of those financial situations would you rather be in? Yeah, I was going to say the second one, I'm hoping. That looks like significantly more here. So it looks like 8 bun 5. Well, why? Well, for the last 1, 2, 3, 4, 5, 6, 7 years, I make more. I mean, shoot, if you can choose between 2 jobs, and one of the 2 jobs is going to pay you more 7 of the 10 years, unless those first 3 years are pretty darn awesome, which they're not in this case, I'm going to choose the one where over the long term I'm going to make more money. So that's the process I want you to think, not just 8 bun 5. Okay, why? Cause. No, no. I need better than that, okay? Even if it was just, well, I make almost $10,000 a year more at the end. That's legit, okay? But some sort of reason would be necessary. And then finally, 33, I'm going to school to become a plumber. The program takes 3 years. Flourishing Flusher School's tuition is $18,000 and increases by $1,500 yearly. Tantalizing Toilets tuition is $20,000 and increases 2% yearly. Which is the cheaper option by how much? Okay. So we've got Flourishing Flushers here. They didn't give me the equations this time. How obnoxious. So $18,000, and it goes up $1,500 every year. So there's my Flourishing Flusher. Okay, Tantalizing Toilets. I don't know if I'd go there just because that's kind of a frightening name. $20,000, but it increases by 2%. That's my growth equation. So once I kind of work that through, I'm going to do the same thing I did back with my job offers on the last problem. And get that typed in. And again, what am I doing? Now this time I have a little bit different of a plan that I'm looking at. I'm trying to figure out over 3 years, and here's one thing some of you did on the last quiz that I want to fix you on. Year 0 is the first year. So if I'm going to school for 3 years, we're going to compare 0 through 2. 0, 1, 2, 3 years. So you're like, okay, so do I just look at the end? No, you've got to look at the sum total. So, like for instance, on my first one, I'm going to add those 3 values up. And to be helpful, I'll do that for you. Okay? Otherwise, you could write the 3 numbers down and then go back and add them if you needed to. And then I'm going to do the same thing over here on the right. So if I add those 3 up, I get those written in. And basically, for the most part, we're going to choose, if we're getting the same education, we're going to choose flourishing flusher here. And then again, answer the whole question. Okay, how much of a difference? Don't just say that's better. Don't just say because it's less. Get the value in there. Okay, this is a chunkier version of the quiz preview. Again, of which we will go through tomorrow. But again, you've got to do some to get this right. Even if you're looking at it right now going, no, this is easy. Right, because my mouth is moving. My mouth will not be moving when you are taking a quiz. So you need to look at this. If you need to look at this and say, I want to start looking at the quiz preview, maybe I can do this on my own without just watching the video and filling it in tomorrow. They're still up front. Okay? But do put in some work these next couple of days, and that quiz at the end of the week will look mighty better.